Friends, welcome back. In our previous video, we explored the urgent need for effective plastic waste management and concluded that depolymerization or pyrolysis is the most promising scientific solution. Today, we are diving deeper into the world of pyrolysis technology. In this video, we will delve into the technical aspects of pyrolysis plants, examine various forms of pyrolysis, discuss cost factors and profitability, and explore the quality standards of pyrolysis oil. Join me as we uncover the potential of plastics to profit, pyrolysis solutions for a sustainable future. Let us navigate through the presentation and discover how pyrolysis can transform plastic waste into valuable resource. Plastics to profit. Pyrolysis solutions for a sustainable future. Part 3. Pyrolysis statement. Thermal cracking or depolymerization of a material into gaseous fraction in oxygen-starved condition at elevated temperatures. Pyrolysis reactors, there are two types of reactors, batch type and continuous type. Technical modules of the pyrolysis plant. Shredder. For shredding waste plastics, we use shredders. Autofeeder. Autofeeders are a conveyor system used to carry plastic waste into reactor. For auto charging of plastics, we use autofeeders. Nitrogen purging machine. It's an arrangement to remove oxygen from the inner reactor. Reactor. A large metal chamber with a thermally insulated shell where thermocracking or pyrolysis of plastics takes place at 430 to 450 degrees centigrade. Batch type reactors are rotating and continuous type reactors are stationary. Boiler grade steel is used for making reactors. Condensers. Series of condensers are used to liquefy the hydrocarbon gases or syngas formed inside the reactor. Oil collectors. The liquefied hydrocarbon gases will be collected in oil collectors. Plastic shredder. Plastic shredders are used for cutting waste plastics into small particles. There are different brands of plastic shredders available in the market. Pyrolysis reactor batch type. A batch type reactor has two components. One is an outer shell and an inner rotating chamber. The outer shell is a stationary type. It is filled with insulating materials like silica wood to prevent heat loss from the inner reactor. The temperature inside the reactor has to be kept constant, steady, for an efficient cracking of plastics. This is a big door of the batch type reactor through which the shredded plastics are fed into the reactor. This is a ball bearing on which this inner reactor is rotating. This is an inner view of the reactor rotating chamber. Blades are provided inside the rotating chamber to mix shredded plastics and catalyst and also to keep uniform temperature inside the reactor. Rear view of the reactor. This is an outlet through which the cracked hydrocarbon gases will come out. Another view of the ball bearing on which the inner rotating chamber is moving. Here, there is a small motor, 5 HP capacity. With the help of this motor, the inner rotating chamber rotates. The hydrocarbon gas formed inside the reactor will come out through this pipeline, and through this pipeline, it enters a series of condensers kept in a row. A nitrogen purger. Nitrogen purger used for removing oxygen from the inner reactor. Heating area. The reactor has to be heated from the bottom. Different heating sources are used. LPG, coal, and even wood can be used for heating the reactor. Condensers, vertical condensers in a row, different hydrocarbon molecules may have different boiling points, and therefore the liquefaction takes place at different temperatures. The low boiling point hydrocarbon gases will liquefy last, and high boiling point hydrocarbon gas will condense first. So we get different hydrocarbon fuels at different oil collectors. This is oil storage facility. The oil or the fuel collected at different oil collectors after removing water by centrifuging technique is stored in this oil storage facility. Scrubber is inevitable to purify the flue gases comes out from the reactor. The flue gas may contain suspended particles and water-soluble impurities. And when these flue gases pass through this water tank, the suspended particles and water-soluble impurities are removed. And the pure air which comes out from this scrubber will be sent to the chimney, and finally it will be given out to the atmospheric air. It's a fireplace. The non-condensed gas in the pyrolysis process can be flared up here. If the owner of the plant is not interested to utilize the non-condensed gas formed in the process, then the gas has to be burnt here. It will be very difficult to store and keep these highly inflammable non-condensed gases. Therefore, if the non-condensed gas is not used in the reactor, then it has to be flared up. If the investor decides to utilize the non-condensed gases formed in the process, then he has to store the non-condensed gases in the gas balloons initially. And from there, these are brought to the reactor for firing. This is a continuous type pyrolysis plant. It's a full plant. The reactor used here is stationary type. It will not rotate. And the shredded plastics will be fed into the reactor through a conveyor system and a hopper. The temperature of the stationary reactor has to be maintained between 430 to 450 degrees centigrade. Here, the heating is not done from the bottom. Instead, hot air is circulated through this double-jacketed reactor. As soon as the temperature reaches 450 degrees centigrade, the complex molecules of plastics get cracked, thermally cracked, and hydrocarbon gases will be formed. The molecular weights of plastics starts from 50,000 to 2 lakhs. Plastics are long-chain hydrocarbons, and these long-chain hydrocarbons on thermal cracking will be converted into short-chain hydrocarbons of various types. The short-chain hydrocarbons of a different nature will come out, and they will get condensed at different condensates kept in a row, and the different types of fuels will be collected at different fuel collectors or oil collectors. Because of copyright issues, full video of working pyrolysis plants cannot be shown here.
However, a short video is playing here
to show the oil formation. It's very clear in the video that very good quality plastic oil is formed. Pyrolysis oil is formed in a plant, and it is only a short video. Unable to show full video. Pyrolysis, different types. There are different types of pyrolysis. Very slow pyrolysis, fast pyrolysis, and plasma pyrolysis. Very slow pyrolysis is usually used for converting biomaterials and tire material into oil. Biomaterials will give oxygenated oil tire will give hydrocarbon oil. The heating rate in very slow pyrolysis is 5 degrees centigrade per minute, and the cracking temperature is usually 350 degrees centigrade. In biomaterials like a coconut shell, the thermal cracking starts from 200 degrees centigrade to 350 degrees centigrade. Between these temperatures, hemicellulose, cellulose, and lignin starts decomposition, and oxygenated hydrocarbon gas will be formed, and this gas on liquefaction we get bio oil of the the remaining fraction of the biomaterial will be good quality charcoal. In tire also we get oil, fuel, but the oil is of a hydrocarbon nature. Around 40 to 45% will be hydrocarbon oil, and some 40 to 45% carbon will also be formed in tire pyrolysis. In slow pyrolysis, we use generally plastics. The rate of heating in slow pyrolysis will be little higher, 10 degrees centigrade per minute, and the cracking temperature is 450 degrees centigrade. Good quality furnace oil will be formed in slow pyrolysis. Fast pyrolysis. Fast pyrolysis is also known as catalytic fast pyrolysis. The heating rate in catalytic fast pyrolysis will be higher, 10 to 20 degrees centigrade per minute, and the cracking temperature is further raised to 550 degrees centigrade. Here we use the efficient catalysts like alumina and zeolite. Plasma pyrolysis is the highest version of pyrolysis, highest level of pyrolysis. It takes place with the help of plasma arc at a very high temperature, 10,000 degrees centigrade. Usually, municipal solid waste can be converted into electricity and other forms of energy with the help of this technology. Catalytic fast pyrolysis. Researchers reported that catalytic reforming of plastic pyrolysis vapors at higher temperatures, say 550 degrees centigrade, gave better yields of good quality naphtha. But such studies are yet to be commercialized. This is reforming chambers in catalytic fast pyrolysis. The chambers are filled with efficient catalysts like alumina and zeolite. Two different types of reforming chambers are shown in the picture. As soon as the reforming completes, the hydrocarbon gas which comes up from slow pyrolysis will get cracked in these chambers, and short chain hydrocarbons will be formed, and good quality naphtha and some amount of lubricating oils are also formed. Mechanism of cracking. In this process, there are three steps: chain initiation, chain propagation, and chain termination. In the first stage, cracks large polymer molecules into free radicals, and in the second stage, chain propagation, free radicals and molecules are further cracked into smaller radicals. In chain termination, the radicals formed in chain propagation will combine to form stable molecule. Types of cracking: random cracking and chain strip cracking. Random cracking takes place in majority of the molecules, but chain strip cracking takes place in molecules having side chain like styrinated phenol. Influence of secondary cracking process, catalytic fast pyrolysis. Secondary cracking process can be controlled by high temperature, 550 degrees centigrade. Catalysts like zeolite and alumina are used here. It is already mentioned in the previous slides. If polyethylene is subjected to catalytic fast pyrolysis, we can just compare the outputs in slow and fast processes. In slow pyrolysis, non-condensable gases formed will be around only 18.3%, but the non-condensable gases will be higher in fast pyrolysis, that it comes around 58%. The liquid product will be more in slow pyrolysis, but the liquid percentage will be lower in fast pyrolysis. It comes around 23.7% only. The carbon percentage in slow and fast pyrolysis will be around 1%. Crude oil fractional distillation. In this is a laboratory scale of fractional distillation. In this case, we use a round bottom flask and a thermometer, and here is a condenser and a receiver is there. And the crude pyrolysis oil is kept in the round bottom flask, and it is heated. And depending upon the boiling points, various molecules will be evaporated. The hydrocarbon oil or fuel having lower boiling point will boil first, and the vapors will pass through this condenser, and it is condensed in the reservoir. Depending upon the boiling point, various fractions will come out through the condenser, and each fuel can be collected in different reservoirs kept here. Procedure. See, this is the most accurate form of fractional distillation. The various fractions we collected at different temperatures are shown. Temperature between 25 to 60 degrees centigrade, we get gasoline or petrol. Gasoline or petrol is highly volatile, and it is collected at the lower temperatures. Naphtha is also highly volatile. It is collected between 60 to 180 degrees centigrade. Kerosene, its boiling point is a little higher. It is collected between 180 to 220 degree centigrade. Boiling point of diesel is also higher. It is collected between 220 to 250 degrees centigrade. Fuel oil is collected between 250 to 300 degrees centigrade. Lubricating oil is collected between 300 to 350 degrees centigrade. And above 350, bitumen is the end product. Quality parameters of plastic pyrolysis oil. As per BIS standard IS 16961 2018, the 9 parameters are to be met in pyrolysis oil. Till 2018, there were no quality standards for pyrolysis oil. But as per the BIS standard IS 16961 2018, 9 parameters are to be met in pyrolysis oil: density, viscosity, flash point, sulfur content, ash content, water content, carbon residue, copper strip corrosion, and calorific value. Flash point it should be minimum 40 degrees centigrade, but it varies between 40 to 80 degrees centigrade. In petroleum diesel, it comes around 55, 45 to 55, the flash point. But in pyrolysis oil, minimum 40 should be there. The flash point of pyrolysis oil should be minimum 40 degrees centigrade. But generally, it varies between 40 to 80 degrees centigrade. Calorific value of pyrolysis oil should be minimum between 9,500 to 10,700 kilocalories. Apart from these quality specifications, the pyrolysis unit owner has to follow the guidelines issued by the Ministry of Petroleum and Natural Gases, Government of India. Energy profit of pyrolysis. Energy requirement to pyrolyze 1 kilogram polyethylene is 250 kilocalories. But if we examine the calorific value of 1 kilogram pyrolysis oil, we can see that its calorific value is 10,342. Therefore, it is very evident that energy profit in this project is very high. Energy requirement to pyrolyze 1 kilogram polyethylene is just 250 kilocalories, but we get 10,342 kilocalories from 1 kilogram pyrolysis oil. Therefore, this project is economically viable. Energy profit is very high. Product cost evaluation. The pyrolysis oil, its cost of production per liter comes around INR 25.30 US dollars. Pyrolysis oil market price per liter INR 55 to 65, 0.66 to 0.78 US dollars. In this process, we get a low quality carbon black. Its selling price is around INR 8 and 0.09 US dollars. Before summing up this presentation, I would like to mention about the prices of common pyrolysis reactors. This being an evolving technology, and there is no standardized price for plastic pyrolysis reactors. However, in India, we are manufacturing both batch type and continuous type reactors. The cost of batch type reactors varies between 70 lakhs to 120 lakhs. It depends upon the interest of the manufacturer, and the manufacturer decides the price. But for continuous type reactors, the prices depends upon here also it depends upon the manufacturer. For example, a manufacturer in gaseous valves is charging 1 crore 75 lakhs for a 6-ton capacity plant, continuous type plant. Another manufacturer in Mumbai is charging 5 crores for a 10-ton capacity plant, continuous type plant. But if we are interested to buy pyrolysis plant from abroad, China is making large number of pyrolysis reactors, and the cost of Chinese plant comes around 63 lakhs only for a 10 TPD plant. We need to add some extra amount to the project, because all plant manufacturers are mentioning the cost of the reactors only, and we need to add extra costs like shipping costs, road transportation cost, then installation cost, personal, etc. But one more point: if the investor is interested to go for a high-end technology, and if they are capable to invest more, they can go for advanced pyrolysis technology, and it is available in countries like US. The cost of such a plant will be around $5 million US, and the capacity may be around 40 tons per day. These are something about the cost factors of pyrolysis plants. In conclusion, let us embrace plastic as a valuable resource, not an enemy. By adopting scientific disposal methods, we can unlock its full potential. Pyrolysis, a proven technology, transforms plastic waste into valuable products like petroleum diesel. It is disheartening that despite Kerala government's approval in 2012, the project remains unimplemented. Meanwhile, some other states and nations have successfully adopted this technology. I urge authorities to revisit this project, recognizing its scientific validity and economic viability. Let us join forces to turn plastic waste into a sustainable opportunity. Together, we can create a cleaner, greener future. Thank you for your attention, and let us drive change.